we have yet another trig proof. Tip number 1, when tackling these, we need to get everything into sine and cosine. So we have a cosecant, we have another cosecant, and we have a cotangent. Okay, we're going to want to get rid of those and get them in a sine or cosine. So let's look at our trig identity sheet. We have cosecant here, which is equal to 1 over sine theta. And we have cotangent here, which is equal to cosine over sine theta. Okay? That's all we need for right now. Come back to that if we need it. But let's just make the substitution for step number 1. So we can rewrite this as, left side we're not going to touch because it's already in cosine. So we'll go 1 over 1 plus cosine theta. That's equal to, now for cosecant we said that was 1 over sine. So that means cosecant squared theta is simply 1 over sine squared theta. Right, so that's the first substitution, minus cosecant, again, is simply 1 over sine. So we will write that, 1 over sine theta. And cotangent, the reciprocal of tangent, is cos theta over sine theta. Very good. We now have everything in cos and sine. So we can start to simplify a little bit. Left side we're not going to touch right now, so we have 1 over, actually, you know what, we'll just leave that for now. On the right side we're going to have 1 over sine squared theta minus, now we multiply the numerators and we'll multiply the denominators. So 1 multiplied by cos theta equals cos theta. And the denominators multiplied by each other gives us sine squared theta. Very good. The left side we're not touching still. So, what do you see? Well, you should see common denominators, sine squared theta. Fantastic. That means we can we can collect like terms rather. So we'll have 1 minus cosine theta over sine squared theta. Very good. Okay, what's our next step? Well, we have sine on the bottom, cosine on the top. Great if we could somehow get it into all cosine or all sine so we can cross things out and simplify. I'd like to draw your attention to the denominator. The denominator is sine squared theta. Okay, let's look at on our identity sheet and see if that pops up anywhere. Specifically right here. What we can do is we can move this cosine squared theta over to the right, and we can rewrite it as sine squared theta is equal to 1 minus cosine squared theta. All right? So let's make that substitution. The numerator we're not going to touch right now, so we'll leave that as 1 minus cosine theta. The denominator, we just said, is equal to 1 minus cosine squared theta. Great. Now what do we do? Well, we need to go back to 9th grade math and realize that this denominator is a difference of squares. Difference of squares can be factored, okay? So, we write our numerator the same, 1 minus cosine theta over, remember how to set up difference of squares? What is the difference of squares first? Well, it means that both terms here, both 1 and cosine squared theta, are squares. And difference, that means subtraction. So we can set this up like this. Bracket plus, bracket minus. And what are the two terms here? Well, square root of each term. So we have 1 plus cosine theta multiplied by 1 minus cosine theta. And when you multiply these out, you're going to get 1 minus cosine squared theta. Okay, so all we did is factor that. We factored the difference of squares. Why? Well, because in the next step, you can see that the numerator can cross out with this term. Awesome. So what are we left with? We're left with 1 over 1 plus cosine theta, which is just simply this part that didn't get crossed out. Okay? Let's check in on the question to see where we are, because we've simplified the right about as much as we can. Sure enough, draw this all the way down, and we have 1 over 1 plus cosine theta. Our left side equals our right side. Okay? This one was a bit long, but it's just simple steps. Once you make the substitution based on the trig identity, it's just simplifying. So feel free to pause the video and take a screenshot of that. That's how we did it. Thanks for watching.